This video goes over what the pH is going to be at the equivalence point. So the equivalence point we already calculated was 25 milliliters. And what we would observe is that there is a 1-to-1 molar ratio for acid to the base that we added to completely form our products. Now, the products though, we have water, and we have this conjugate base. So the conjugate base will form an equilibrium. Some of it will go back to form your weak acid. And that is because we have here the HA is going to reach an equilibrium, and you're going to have a little bit that goes back to form your HA. So what you'll see is that if we rewrite this, we have A minus plus water now reaching an equilibrium with our HA plus OH minus. So this reversal of this reaction going back for the little that is going back is, in this case, if we write this out, our equilibrium expression this equation is our K sub B, so our KB. So we need to find what our KB is going to be. And then, once we know our KB, we can solve for our OH minus. We'll solve for our OH minus concentration. We'll find our POH, and then we'll find our pH. Okay, so our KB is equal to Kw over Ka, which equals 1.00 times 10 to the minus 14 over 0.9 times 10 to the minus 5th, which equals, in this case, 1.45 times 5 in the subscript times 10 to the minus 10. So what we'll have is we'll have 1.45 times 10 to the minus 10 equals x squared over, and we'll have a concentration minus x. And so this concentration should be F prime. F prime because we could take this initial concentration, but because we added so much volume of our base to our solution now, it's going to be diluted. So we have to take that into account when we calculate now this concentration here, our formal concentration. So this dilution is going to be, so F prime is now going to be our concentration times our volume divided by the total volume. So that this will be the volume, our initial volume, which is 50.0 milliliters. So this is our initial volume times our initial concentration. So this is basically an M1V1 equals M2V2 equation. So our initial concentration and volume, so this is 0.0500 molar over our final volume, which is 25 milliliters plus 50. So it's, in this case, 50.0 milliliters plus 25 that we added. And then our milliliters will cancel out, and what we will get is 0.0333 molar. So in this case, we'll have 1.45 times 10 to the minus 10, 0.0333 minus x. This concentration is over 1,000 times greater than your K sub B, so this x can be negated. And what you'll find is that your x, which equals your OH concentration, is going to equal 2.20 times 10 to the minus 6. And if you find the POH, that will equal negative log of 2.0220 times 10 to the minus 6 molar, which equals 5.66. So then your pH is going to equal 8.34. Okay, so the pH at your equivalence point is going to be 8.34. Okay, you notice again it's slightly basic because remember it's a conjugate base. So the last part, we are going to find what the pH is after the equivalence point.